Class example 3.57. In a particular body of water, the intensity of light decreases by 15% every 3 meters of depth. Assuming that at the surface the light intensity is at 100%, determine the percentage, correct to the nearest whole number, of light that would be present at a depth of 10 meters, correct to the nearest whole number. So let's start with our growth decay formula on your formula sheet. In this case, our Y value is going to be the end amount, so the light intensity as a percentage of that at the surface. And in this case, this is what we want. Our A value is going to be 100 because it started at 100%. Our B value is, well, it's decreasing by 15%. So our B value is going to be 85%. 85% is remaining. So our B would be 0.85 because it's written as a decimal. Our P value is going to be 3 because our multiplication factor of 0.85 is going to be applied every 3 meters. And our T value is the actual depth. Notice that T probably isn't the best variable in this case because we're really talking about distances, but we're gonna carry on with T for now. Okay, now solving for, we've changed it to L for light, but really you could have left it as Y as well. And if we solve, we get 58.17%, or roughly 58%. We could solve this graphically by simply typing in the equation and then using the trace function on your calculator. So if you go second trace, and then if you just start typing in 10, you'll notice that it'll say x is equal to 10, and then it'll tell you what y would be when x was 10. Okay, B. The depth at which the light intensity would be just 10% of that on the surface, correct to the nearest whole number. So in this case, we want to find T when L is 10%, or is 10. So we divide both sides by 100. And then we'll convert this to a log form to solve for T. So again, if you're having trouble with converting, that's our base in the exponential form. So that's going to be the base in the log form. And then it's of 0.1, so of 0.1. And then solves for the exponent. So there's our exponent. So that's what the logarithm is solving for there. And then multiply both sides by 3. We get roughly 43 meters. We can solve for this graphically as well by graphing y1 and y2. So y1 in this case would be, well, the right side of the equation here. And y2 would be 10. Now notice, actually it would have worked at this point as well. This could have been our y1 and this could have been our y2. The value of x that came out of that would have been the same either way.